Alright kids, today we'll be working on chapter 5 review form. Essentially, this is the study guide for chapter 5. This is the graphing exam. So this is about graphing linear functions, graphing linear inequalities. Okay, let's get into it. So we have two equations. There's the top equation, there's the bottom equation, and we want to graph the system of equation, and we want to state the solution. Okay. So let's start with, let's call this equation A, let's call this equation B, just for easy naming. So equation A, the y-intercept is here, the slope is here, you don't see it, so the slope is 1. So the y-intercept is 1. So we start the y-axis at 1. There's the y-axis, there's the x-axis. So we start at 1. And then the slope is here, is also 1. And so 1 is up 1, 1 to the right. So we go up 1, 1 to the right. 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 So up 1, 1 to the right, it's the same thing as down 1, 1 to the left, down 1, 1 to the left, down 1, 1 to the left. So from here you go down 1, 1 to the left. There we go, continue in this direction. And there's line A. So let's graph line A. Take your student ID card and you draw your line. There we go. And that's line A. And then to draw line B, you can start with the y-intercept of B. That's up 1, 2, 3. Okay, that's the y-intercept. The slope, you don't see it, it's a -1. So you go down 1, 1 to the right. 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 You can also go up 1, 1 to the left. Up 1, 1 to the left. This is line B. Okay, so here is line B. So we graph line A, we graph line B. So graph the system of equations. That is done. State the solution. Well, the solution is the intersection of the two lines. So from here, it looks like we go out 1 and then out 2. So x in direction is 1 and the y direction is 2. So the intersection of the two lines is on the point 1, on 2. That's your solution. You can totally check it. You let x be 1, y is 2. Let x be 1, y is 2. 1 plus 1 is 2. Totally legit. X is 1, y is 2. -1 plus 3 is 2. Totally legit. Okay, so 1 is done. Okay, let's do this one, number 2. So once again, this is equation A, and this is equation B. Let's graph A. Y-intercept is at -2, that's down here. Slope is right here, 1 over 2. Up 1, 2 to the right. Up 1, 2 to the right. Up 1, right out of room. How about if we go this way? Down 1, 2 to the left. Down 1, 2 to the left. There's your line. Okay, take the student ID card and draw your line. Okay, that's equation A. Equation B, well, we start with the graph right here. That's the y-intercept, that's 2. So we go up 2 right here. That's the y-intercept. The slope here is 3 over 2. So you go up 3, 1, 2, 3, to the right 2. Ran out of room. You can also go down 3, 2 to the left. Down 3, 2 to the left. Down 3, 2 to the left. Oh, I think I found the point of intersection. Right there. Okay, let's draw this line. Line B. This is line B. So the intersection of A and B, the intersection of y is equal to 1 half x minus 2 and y is equal to 3 over 2x plus 2 is right here. So we graphed it, right on. State the solution. The solution looks like it's on the corner of -4, -4. There you go. And there's the intersection of the two lines. Alright, let's move on to number 3. Graph the system of equation, state the solution. Well, we're doing the same problems over and over again. Well, let's see. This is line A, this is line B. To graph A, there is a y-intercept at 2. The slope is 2. Up 2, 1 to the right. Ran out of room. Down 2, 1 to the left. Down 2, 1 to the left. Down 2, 1 to the left. Okay, that's line A. There it is. Draw the line. There's line A. Next, line B. Y-intercept is -2. -1, -2 right over here. Slope is 2. Up 2, 1 to the right. Up 2, 1 to the right. Up 2, 1 to the right. Or down 2, 1 to the left. Down 2, 1 to the left. Down 2, 1 to the left. Run out of room. Okay, let's connect these points. There is line B. So, you graph the system of the equation. The solution is the intersection of the two lines. Impossible. Notice the slopes are the same. The slopes are the same, the lines are parallel. They never intersect. So the solution would be no solution. Intersecting lines will never meet. So how can there be an intersection? Can't. No solution. Alright, number 4. Now this one. Oh, how are we going to graph this one? We can find the x and the y intercept because it's written in standard form. But not feeling it. You can do it, but I just feel so much more comfortable using the slope-intercept form. So I'm going to graph line A, I'm going to graph line B, but before I can graph it, I'm going to move it from standard form into what is called the slope-intercept form, because it's way easier to graph when I know the slope and the y-intercept. Okay, so here is equation A. To solve for y, we have to start with getting rid of what's not y, starting with that x. So I'm going to minus x to both sides. Minus x here, minus x here. And I end up with -2y is equal to minus x plus 2. Not showing the work. I hope you can figure it out because there's no room. And then we almost got y. We have to divide by -2 to both sides. Okay, I'll show the work here. So divide by -2, divide by -2, and divide by -2. So that becomes a 1. 1y. Now, that's a coefficient of -1. -1 over -2 is positive 1 over 2. There's that x. And then plus 2 divided by -2, it's just going to be -1. So this is much friendlier to graph. So let's graph it. Let's graph line A. The y-intercept is at -1 down here. The slope is right here, the coefficient of the x. 1 over 2. Not 1 over 2x, just 1 over 2. So up 1, 2 to the right. Up 1, 2 to the right. Ran out of room. Let's go this way. Down 1, 2 to the left. Down 1, 2 to the left. That's equation A. Right on. Let's graph equation B. Not nice. This is in... Actually, this is not so bad. Okay, let's just stick with the plan. So let's go 2x minus 4y is equal to 4. I was going to work this out using the x and the y intercepts, but I just stick with the plan. So we want to get y by itself, so we have to undo that 2x. So we have to minus 2x here, we have to minus 2x here. Yeah, -4y is equal to minus 2x. plus 4. And then you have to divide through by negative 4 here, and here, and here. There's no room. So you divide this by negative 4, you get y. Divide this by negative 4. See how it's negative 2 over negative 4? That's positive 2 over 4, or 1 over 2. Not showing a lot of work again, but there's just no room. And then you divide that by 4, and then 4 divided by 4. Well, that's just going to be 1. Is it plus 1 or minus 1? It's, oh, I divided by negative 4. 4 divided by negative 4, that's negative 4. Good thing I checked. Could have screwed that up. Divided by negative 4. Okay, that's legit. Okay, so now we can graph equation B. The y-intercept is at negative 1. Oh, right here. And then the slope is 1 over 2. Oh, up 1, 2 to the right, up 1, 2 to the right. It's the same line. Right, Ms. Trout? So this equation A and this equation B, as it turns out, it's the same equation. So A is the same thing as B. Looks different, but it's the same. Actually, if you multiply the top equation by 2, which is what it's called multiplication property of equality, you get exactly this. So the two equations, it's the same, they're equivalent. Okay, so we graphed it. The solution will be the intersections. Here's an intersection, here's another intersection, here's another. So they have all these points. Every point on this line they have in common. So let's take the solution. It would be infinitely many solutions. There you go. Okay. Almost worked out of the. Okay, let's do 5, 6. Okay, so once again, here's the top is A, the bottom one is B. But notice that we don't have equations anymore, we have inequalities. So instead of a line, it's more like a territory. It certainly is a line, there's a border, and then is it above, below, right, left. So let's work it out. I'm going to graph the system of equation. Y is greater than 2. We start out with y is equal to 2. That means the y-intercept is at 2. No x-intercept. Oh, so it's just going to be a horizontal line. But what kind of a horizontal line? See that greater than? It doesn't have an equal sign to it. If it doesn't have an equal sign, it's a dotted line. So dot, dot, dot. And it's greater than 2. So it's all points this way. And that's territory A. So if that's like 2nd Street, the A crew can hang out above the line, not below and not on the line. B. The B y-intercept is at 3. 1, 2, 3, right here. That's the y-intercept. The slope, you don't see it, it's a 1. So up 1, 1 to the right, up 1, 1 to the right, ran out of room. Down 1, 1 to the left, down 1, 1 to the left. There we go. There it is. Now, this is less than or equal to. Equal to means it can be that line. So, okay, just do an ID card and draw a solid line. And this is less than. So less than, would that be above or below? Less than is below. So this is area B. So look at this intersection of the two lines. Here's a solid line, here's a dotted line. Group A can only hang out above this line. Group B can only hang out below this line. So there's area 1, area 2, area 3, area 4. Where is it that A and B can coexist? Is it 1? No. A can hang out at 1, but not B. Is it 2? Yes. And area 2 is good for A, and it's good for B. So I think the solution is in area 2. Well, let's continue with 3 or 4. Area 3, only B can hang out, not A. And area 4, nobody can hang out. So the solution we're looking for is in area 2. So let's just darken these lines over here. There we go. So it's all this business here. So all along this line, not on this line because this is the dotted line, and all in here. So all in here and this line, and of course infinitely that way. So we graphed it and we state a solution. So what's a good point? How about this point right here? So it looks like it's 1, 2 to the right, 1, 2, 3. So 2, 3 is a solution. How many other solutions are there? Infinitely many. I just picked one. All right, number 6. Here we have this inequality. And it's so nice that it's written in slope-intercept form for us. Here's the inequality A, and here's the inequality B. Okay, so to graph A, the y-intercept is at 2. 2 right there. Slope is -2, or -2/1. So go down 2, 1 to the right, down 2, 1 to the right, down 2, 1 to the right, up 2, 1, 2, 1 to the left. No more room. So I draw a line. The A does not have an equal sign, just greater than, so dotted line. Dotted line. And then this is greater than, so this is above, this is below, above, below, above, below, greater than, so it's above. So this is where the A crew gets to hang out above this line, but not on the line. Okay, the B crew, y-intercept is at -1. Slope is 3, or 3/1, so you go up 1, 2, 3, 1 to the right, 1, 2, 3, 1 to the right. You can go down 3, 1 to the left. This has an equal to sign, so solid or dotted? It would be solid because it has an equal to sign. And then you have to say, is it above, below, above, below, above, below? This is less than is below. So this way, below this line, and that's area B. So here's an intersection. Here's area 1, here's area 2, here's area 3, here's area 4. Where is it that A and B can hang out together? Above this line, below that line, above that line, below this line. So it looks like area 2 is your solution. So I graphed it and I state a solution. 1, 2, 1, 2. That's a safe bet. 2, 2. And there are infinitely many more. Okay, you believe it? That was the first page. So now let us go to the second page, number 7. All right, let's do number 7. Given the system of inequalities, y is less than blah, 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 and that graph the system. Oh, so we graph this. All right, that's the A inequality. This is the B inequality. So let's graph it. To graph A, we start with a y-intercept of -4. -1, -2, -3, -4. And then the slope is 2. 2/1. Up 2, 1 to the right. 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 There we go. See that equal to sign? That means it's a solid line. Yes, it is. Above, below, less than, below. So this way. And that's where the A crew hang out. That's graph B. Y-intercept? You don't see it. It must be a 0. Right here. Slope is 1 over 2. So up 1, 2 to the right. Up 1, 2 to the right. Down 1, 2 to the left. Down 1, 2 to the left. See that inequality? Less than or equal to. Equal to means it's a solid line. Less than means it's below. That's where the B hang out. So it has to be below this line, below that line. So it looks like it's this area that's legit for A and for B. This spot right here. So all this over here. This spot. So we brought the inequalities. Okay, so now algebraically show whether each of the following are solutions of the system. Negative 3, 3. 1, 2, 3. 1, 2, 3. Right here. No. 3, negative 3. 1, 2, 3. 1, 2, 3. Right here. Oh yeah, that's a yes. So that's A, that's B, that's a yes. Negative 2, 3. Negative 2, 1, 2, 3. Oh no, I don't think so. 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. Oh, just misses. No. Oh, but it says algebraically show whether each of the system are the solutions. I screwed it up. I solved it graphically, not algebraically. So here's what we have to do. We have to look at the top equation right here, and we have to plug in x and y. So equation A. Y is less than or equal to 2x minus 4. We let x be negative 3, y be negative 3. So negative 3 less than or equal to 2 times negative 3 minus 4. Okay, we got negative 3 here. 2 times negative 3 is negative 6. Minus 4 is negative 10. Is negative 3 less than negative 10? Oh no. No, no, no. Oh. I just put it in A. I didn't even put it in B. But I don't have to put it in B. I just have to say it's no for 1. If it's no for 1, then it's no for the whole thing. So with this over here, if you plug it in, I'm willing to say that's going to be yes for here and yes for here. So we have to go y is less than or equal to 2x minus 4. Let x be 3. Y is negative 3. Negative 3 is less than or equal to 2 times 3 minus 4. Negative 3 is less than 2 times 3, which is 6, minus 4, which is 2. Negative 3 is less than 2. Yes, it is. Okay, now we do equation B, which is y is less than or equal to 1/2 x. We let x is 3, y is negative 3, negative 3 here, and x is going to be 3, or 3 over 1. So that's going to be negative 3 is less than or equal to 3 over 2. That's 1/2. It's a positive number. So a negative number is less than a positive number? Oh yeah. And then with these two guys, I just have to plug it in one of the inequality, and it just got to be no for one. It doesn't have to be no for both. So let's try, let's do an easy one. Let's do B. So let's try y is less than or equal to 1 over 2x. I let y be 3. I let x be negative 2 times negative 2, or negative 2 over 1. I get 3 is less than or equal to b. That's going to be negative 1. 3 is less than negative 1? Oh, no. No, no, no. So I don't even have to do the other one, because it just have to be no for 1, and that's it. Now, I already know the answer is no here, but I have to do it algebraically, because I want full credit for this. So I'm going to plug in the easy one. Hopefully that's going to be no. So it's y is less than or equal to 1 over 2x. Y is 3. X is 5. Or 5 over 1. Is 3 less than or equal to 5 over 2? 5 over 2 is 2.5. Is 3 less than 2.5? No. So since I get one no, I can stop, because all I need is one no. If I want yes, they both have to be legit. All right. Next, compare and contrast the outcomes in part 1, 2, 3, and 4. Compare and contrast part 1, part 2, part 3, part 4. What can we say? What can we say? Compare and contrast the outcomes of 1, 2, 3, and 4. Well, I can say that negative 3 is not a solution for A. So I don't need to say it's not a solution for B. Well, and then I suppose I can say that negative 3 is a solution. So this is 1, this is I, this is double I. It's a solution for both A and B. And then for part 3, I can say that negative 2, 3 is not a solution for which equals this is part B. I don't even know if it's a solution for A, but I just know that it's not a solution for B. Then it doesn't matter if it's a solution for A or not. And then finally, part 4. I can say that 5, 3 is not a solution for what I plugged this in. This is form B. So the only thing that's a yes is part 2, and we can say that part 2, the point 3, negative 3 is a solution for both A and B. I suppose there's a lot more that we can say, but yeah, that's enough. Okay, so let's go on to number 8. Number 8. For each pair of equation, what are we supposed to do with this? Describe the number of solutions the following system of equation has. Justify the reasoning in part A. So we want to know the slope, the y-intercept. Okay, so I suppose we're talking about something like this here. Okay, well, this is in standard form, so I need to put in slope-intercept form. Okay, so I got a couple of things. So first, I'm going to work with this. 6x minus 2y is equal to negative 4. And then, we can call this A and call this B. So here's the equation A. Makes it easier to keep track of. Okay, we want to solve for y, so we're going to minus 6x to both sides. So I end up with negative 2y is equal to minus 6x minus 4. I'm going to divide through by negative 2. And then I have y is equal to 3x plus 2. There we go. So now for part B, we got y is equal to 3 times the quantity of x plus 2 over 3. So here's a weird format. It's almost point slope form. We distribute at 3. We got y is equal to 3 times x. And then 3 times 2 over 3. And that's going to be 2 times 3, which is 6. 6 over 3. So it's plus 6 over 3. Which is, of course, just 2. So y is equal to 3x plus 2. So the slope is 3. The y-intercept is 2. Slope is 3. The y-intercept is 2. It's the same. So it must be the same line. We thought there were two different lines, but it's the same line. It looks different up here, but it's the same line. So if it's the same line, then it must have many, many, many solutions. So in part A, this is going to be infinitely many solutions. Same slope, same y-intercept, same line. Of course, there's going to be many solutions. Okay, so on this part, let's first work with the top part. 3x plus 2y is equal to negative 5. To solve for y, I'm going to minus 3x to both sides. F 2y is equal to minus 3x minus 5. Then I'm going to divide through by 2. So y is equal to negative 3 over 2x minus 5 over 2. That's 2.5. So the slope for the top part is negative 3 over 2. The y-intercept is negative 5 over 2 or negative 2.5. Okay, that took care of the top part. Now let's do the bottom part, this one right here. We have 3y is equal to x plus 6 plus 9x. So we can get y by itself by divide by 3. And then we have y is equal to 2 plus 9 divided by 3 is 3x. We should probably write this in the proper format, which is y is equal to 3x plus 2. So now, I know the slope, I know the y-intercept. Slope is 3, y-intercept is 2. So now, these lines are completely different. Different slopes, different y-intercept. So the thing is, if the slopes are different, they're guaranteed to intersect. So there'll be one solution. One distinct solution. So these two lines will meet at a corner of x and y. I don't know what they are because I haven't solved for it, but I know there'll be one solution. Alright, this guy over here. First, let's use 2y is equal to 6x minus 10. Get the y by itself, we divide by 2. We have y is equal to 3x minus 5. Right there. So the slope is 3. The y-intercept is negative 5. Okay, I took care of the top. Let's do the bottom equation. Y is equal to 2 plus 3x. Where do you have the y by itself? This just looks funny, so switch it. If y is equal to 3x plus 2. So now we know the slope is 3, the y-intercept is 2. So with these two lines, the slopes are the same, and the y-intercept is different. So with this one, it starts at negative 5, and it goes up 3, 1 to the right, up 3, 1 to the right. This one starts at the y-intercept of 2, and then up 3, 1 to the right, up 3, 1 to the right. So these lines are parallel because they have the same slope and different y-intercept. So parallel lines have no solution because parallel lines never intersect. So this would be no solution. Okay, so part B, justify your reasoning in part A. Infinitely many solutions, right? We say same slope, same line. Oh, same slope, same y-intercept. Same y-intercept, which is, of course, same line. So if it's the same line, then they intersect itself all over the place. So that's why it's many solutions. One distinct solution, so different slopes. So if they have different slopes, then they're guaranteed to intersect, right? One line goes like this, the other line goes like that. There's your intersection. So it's one solution. No solution, because the lines are parallel. So we say parallel lines do not intersect. So no solutions. And since the slopes are the same and the y-intercepts are different, so of course they're going to be parallel lines, because parallel lines have the same slope, different y-intercept. All right. I think we're almost done. Oh my goodness. Okay, this is page 3. All right, let's rock this. Given the system of equations shown below, select the points that are solutions to this. All right, let's do it. This 4x minus y is greater than negative 3. It's in standard form. Not nice. I'm going to put it in slope-intercept form to make it easier to graph. I'm going to minus 4x to both sides. Minus 4y is greater than minus 4x minus 3. I don't like the negative y. I want a positive y. So I can multiply through by negative 1, or I can divide through by negative 1. So I can change it to a positive y. So divide by negative 1 to all sides with positive y. Direction change this way because I divide by a negative number. 4x plus 3. Okay, there's the top equation. The bottom one. X plus 3y, I said equation, I meant inequality, is greater than or equal to 6. So first minus x to both sides. 3y is greater than or equal to minus x plus 6. Divide 3 by 3. Y is greater than or equal to negative 1 over 3x plus 2. There is the bottom one. Okay, so we graph the top, we graph the bottom, we'll see what happens. Alright, x is less than 4x plus 3. The y-intercept is at 3. 1, 2, 3, right here. Slope is 4 over 1. So up 4. 1, 2, 3, 4. 1, 2, right. Or down. 1, 2, 3, 4. 1 to the left. 1, 2, 3, 4. 1 to the left. 1, 2, 3, 4. 1 to the left. It's less than. So it's below, and it's a dotted line because there's no equal to. And it's below, so it's this way because it's less than. This is above, below, above, below. Okay, let's graph this guy. Y-intercept is 2. 1, 2, right here. And then the slope is negative 1 over 3. So we're going to go down 1, 1, 2, 3 to the right. Down 1, 1, 2, 3 to the right. Down 1, 1, 2, 3 to the right. You're up 1, 1, 2, 3 to the left. Up 1, 1, 2, 3 to the left. And it's a solid line because it has the equal to bit. So let's draw a solid line. there. And it's greater than or equal to, greater than, so it's above, so it's this way. So where is that solution? It has to be below this line, has to be above this line. So it's this area right here. All this area right in here. So graph the system of equations, select the points that are solutions to this system. C looks like it's legit. A is no good. Is there any number on the line? Is this no? No, that's it. C is the only solution. That's not so bad. Alright, number 10. Number 10. Oh my goodness. Graph the system of inequalities below. Select the points of the solution. So I guess 9 and 10 are just alike, right? Let's figure it out. Alright, first put this into slope-intercept form. 5x minus y is greater than negative 3, minus 5x to both sides. Negative y is greater than negative 5x minus 3. I don't want the negative y, I want a positive y, so I'll multiply through by negative 1. Negative 1 times this, that gives you y. If I multiply by negative 1, the direction change. Negative 1 times negative 5x, that's positive 5x. Negative 1 times negative 3 is positive 3. So notice that became opposite, that became opposite, that became the opposite, that became the positive. Because we multiplied by negative 1. Okay, there's the top part. There's the bottom part. X plus 4y is less than 8. To solve for y, undo the x minus x. 4y is less than minus x plus 8. Divide 3 by 4. Yep, y is still less than, that's negative 1/4 x, and that's plus 2. There's the bottom line. Okay, let's graph the top. Y-intercept is at 3. 1, 2, 3. Slope is 5, so up 1, 2, 3, 4, 5. 1 to the right. That's a steep slope. Down 1, 2, 3, 4, 5. 1 to the left. 1, 2, 3, 4, 5. 1 to the left. Get my student ID card. Draw this line. Solid or dotted? Just less than, no equal to, so dotted. And then, where is it? It's less than. So above, below, less than. It's this way. Okay, that's the top line. Bottom line, y-intercept is at 2. 1, 2, right here. The slope is negative 1/4. So you're going to go down 1, 1, 2, 3, 4. Down 1, 1, 2, 3, 4. You can go up 1, 1, 2, 3, 4 to the left. Up 1, 1, 2, 3, 4 to the left. So let us draw this line. But is it dotted? Is it solid? To find out, you have to look at the inequality. It's less than, not less than or equal to. So dotted line. So less than is below. Above, below, above, below. Okay, so now it has to be to the right of this line, below this line, below this line. So it looks like it's all set of points. It's right here. All set of points this way. So G. G looks legit. J. Yeah, J is legit. So here's J. Here's G. F. F is legit. E. Yeah, E is good. F, G, J. Like that. 1, 2, 3, 4. Okay, that's it. One last problem. Then we're done this try. Number 11. The vocabulary. Define the following and sketch an example. Oh my goodness. A distinctive solution of a system of equation. What's another word for this? That's an intersection. So a sketch would be one line this way, one line that way, and there's an intersection. Okay? No solutions. That means the lines are parallel. So parallel lines, no intersection. So it has no intersection. There's no solution. So infinitely many would be like a line like this, and then a line like this. So that this point and this point and this point are all share in common. It's the same line. So same line gives you many solutions. Many solutions or infinitely many solutions. Okay. A solution area of an inequality. So an area would be like, if one line goes like this, and it's below this line, and one line goes like this, and it's below this line, and it has to be below this line, so there is the area where it's legit for both. So if one is this way, and one is this way, so it has to be above this line, has to be below this line, so this is legit area. So it just depends on how the inequality goes. Okay, sketch a linear inequality that includes solutions. Let's sketch a linear inequality. Well, that's the same thing, isn't it? Solution area of an inequality. Oh, so the solutions would be an area where it satisfies both equations or both inequalities. So maybe we should write that. The area that satisfies both inequalities. Sketch an area that, so let's say one is like this and it's this way, and one is like that and it's this way, then here's our area that's legit for both. Okay. Finally, sketch a linear inequality that excludes solutions. So, oh, this is a fun one. Let's say you have two parallel lines. Okay, area A is allowed to hang out here. Area B is allowed to hang out here. So parallel lines, A has to hang out this way, B has to hang out that way. There is never going to be an intersection of the two. So this one has no solution. It's an area. So up here, it's two lines, no solutions. Over here, also no solutions, but it's all this. Like I'm allowed to hang out up here, and you're allowed to hang out down here. We'll never intersect. That's okay. We'll never see each other. Except during class. Okay. I think that's all of the problems that I have. So, good luck on your exam tomorrow. I hope you rock it. And if you don't, well, study. Then take it again. So, watch the video. I hope it was good for you. You didn't get it? Watch it again and watch it again and watch it again as many times as you like. All right, I'm out. Bye bye, everybody.